In 2026, the electrical engineering landscape has never been more complex. And if you're not using MATLAB, you're already behind. Here's why. Whether you're designing the next generation of power systems, developing autonomous vehicle electronics, or optimizing renewable energy grids, there's one tool that's become absolutely essential for electrical engineers. Let's talk about MATLAB. First, let's address the elephant in the room. MATLAB isn't just popular, it's the industry standard. Over 5,000 universities teach with MATLAB, and millions of engineers worldwide use it daily. But here's what matters in 2026. Every major electrical engineering company, from power utilities to semiconductor manufacturers, from automotive to aerospace, expects you to know MATLAB. It's listed in over 80% of electrical engineering job postings. This isn't about following trends. This is about speaking the same language as your colleagues, your clients, and your industry. Let's get technical. MATLAB and Simulink give you something crucial: the ability to simulate before you build. Designing a three-phase inverter for an EV charging station, you can model the entire power electronics system, test it under fault conditions, and optimize efficiency before touching a single component. Working on grid integration for solar farms, simulate years of operation in minutes, test scenarios that would be impossible or dangerous in real life. In 2026, with components more expensive and projects more complex, the cost of getting it wrong has never been higher. MATLAB lets you fail fast and succeed faster. But here's where MATLAB really shines in 2026 real-time capabilities. With MATLAB's hardware-in-the-loop testing, you can connect your simulations directly to physical hardware, test your motor control algorithms on actual motors, validate your protection schemes on real circuit breakers. This bridge between simulation and reality is what separates good engineers from great ones, and MATLAB makes it seamless. Now, let's talk about what makes 2026 different. Artificial intelligence isn't the future anymore, it's the present. Electrical engineers are using machine learning for predictive maintenance on power systems, optimizing energy consumption in smart buildings, and developing adaptive control systems for complex machinery. MATLAB's integrated AI and machine learning tools mean you don't need to be a data scientist to leverage AI. You can train neural networks to predict equipment failures, use reinforcement learning to optimize power distribution, and implement a computer vision for automated inspection, all within the same environment where you do your electrical engineering work. This integration is game-changing. Here's another reality. Electrical engineering in 2026 isn't just about circuits anymore. You need signal processing for sensor data, control systems for automation, power systems analysis for grid work, communications for IoT devices, image processing for quality control. MATLAB's toolbox ecosystem gives you specialized, verified, and optimized tools for every site. Instead of piecing together 10 different software packages, you have one integrated environment. This isn't just convenient, it's powerful. Your signal processing workflow can feed directly into your control system design. Your power systems data can drive your optimization algorithms. Everything talks to everything. But what about deployment? This is where MATLAB really proves its worth. With automatic code generation, your MATLAB algorithms can become C or HDL code for embedded systems. That control algorithm you've perfected in simulation. Deploy it directly to a microcontroller or FPGA in 2026, with the explosion of edge computing and IoT devices. This path from simulation to production-ready code is invaluable. You're not just designing, you're delivering. Let's talk about something engineers often overlook: communication. MATLAB's live scripts combine code, results, and formatted text in one document. Your analysis becomes self-documenting. Your simulations become shareable presentations. In an era of remote teams and complex projects, being able to clearly communicate your technical work isn't optional, it's essential. MATLAB makes technical documentation almost automatic. Here's the bottom line for 2026. The electrical engineering field is moving fast. Renewable energy integration, electric vehicle infrastructure, smart grids, 5G and beyond, industrial automation. These aren't future trends, they're current projects. Engineers who can quickly prototype, simulate complex systems, integrate AI, and deploy production code have a massive advantage. Your competitors are using it, your future employer expects it. The projects that will define your career require it. So why does every electrical engineer need MATLAB in 2026? Because it's not just software, it's your competitive advantage. It's the bridge between theory and practice. It's the common language of modern electrical engineering. The question isn't whether you should learn MATLAB. The question is, can you afford not to? If you found this useful, drop a like and subscribe for more electrical engineering content, and let me know in the comments, what are you building with MATLAB in 2026?